Hi everyone, welcome to my channel ASP.NET and SQL Academy. In this video, I will be discussing 5 important SQL interview questions. Whether you are a beginner or an experienced developer, these questions will help you sharpen your SQL skills. So, let us dive in. In this session, we will be discussing the fundamental concepts of primary keys, unique keys, and foreign keys in SQL. These are crucial for database design and ensuring data integrity. Let us get started. Before we get into the specifics, let us quickly define what a key is in a relational database. A key is a column or a set of columns that uniquely identifies each row in a table. Think of it like a unique identifier for each record. We will be looking at 3 types of keys today. First, the primary key. A primary key is a special type of key that uniquely identifies each row in a table. It must contain unique values and it cannot contain null values. It is the most important key in a table and it is essential for data integrity. In this example, the ID column is our primary key. Notice that every value is unique and there are no nulls. Next, we have the unique key. A unique key, like a primary key, ensures uniqueness within a column or set of columns. However, unlike a primary key, a unique key can contain a null value but only once. You can have multiple unique keys in a single table. In this example, the email column is a unique key. This means no two employees can have the same email address. It is also important to note that a primary key is implicitly a unique key, but a unique key is not a primary key. Finally, let us talk about foreign keys. Foreign keys are used to establish relationships between tables. A foreign key in one table refers to the primary key of another table. This creates a link between the two tables, allowing you to easily retrieve related data. In this example, department ID in the employees table is a foreign key referencing the ID column, that is the primary key in the departments table. This means each employee is associated with a specific department. Let us summarize the key differences. Primary keys are unique, cannot be null, and there is only one per table. They uniquely identify each row. Unique keys are also unique but can have one null value and you can have multiple per table. They ensure uniqueness in a column or set of columns. Finally, foreign keys establish relationships between tables by referencing primary keys in other tables. Let us summarize the key differences. Primary keys are unique, cannot be null, and there is only one per table. They uniquely identify each row. Unique keys are also unique but can have one null value and you can have multiple per table. They ensure uniqueness in a column or set of columns. Finally, foreign keys establish relationships between tables by referencing primary keys in other tables. Let us look at a practical example. Imagine an e-commerce database. We might have a products table with a primary key product ID, a customers table with a primary key customer ID, and an orders table The orders table would have foreign keys referencing both the prime product ID and customer ID, linking orders to specific products and customers. So, there you have it. A clear understanding of primary, unique, and foreign keys is fundamental to effective SQL database design. Remember their key differences, and you will be well on your way to building robust and reliable databases. Thanks for watching. Don't forget to like and subscribe for more tips. Hello everyone and welcome. In this session, we will be clarifying the differences between two important SQL objects, views and synonyms. While they might seem similar at first glance, understanding their distinct characteristics is crucial for effective database management. Let us dive in. Let us start with views. A view is essentially a virtual table. It does not store data itself. Instead, it is a stored query that acts like a table. When you query a view, SQL executes the underlying select statement to retrieve the data. Think of it as a customized window into your data, showing only the information you need. Views can simplify complex queries and provide a level of data abstraction. Here is an example. We have a customers table with many columns. We create a view called high value customers, which only selects customers with a value greater than 1000. This view does not store this data separately. It dynamically generates the result when queried. Now, let us look at synonyms. A synonym is simply an alias for or alternative name for an existing database object, whether it is a table or a view. It acts as a shortcut, allowing you to refer to the object by a different name. Synonyms don't change the underlying object structure or data. They just provide a different way to access it. In this example, we create a synonym, my customers, for the customers table. Querying my customers is exactly the same as querying customers. It is just a more convenient name, potentially making your queries more readable or easier to remember. Let us summarize the key differences. Views are virtual tables based on queries, while synonyms are aliases. Views can have different structures and permissions than their underlying tables, while synonyms inherit these attributes. Views can be updatable, whereas synonyms cannot be updated independently. When should you use which? Views are ideal for simplifying complex queries, providing data abstraction, and controlling access to specific data subsets. Synonyms are useful for simplifying long or complex object names, improving code readability, and providing a layer of abstraction when object names change. So, that's the difference between views and synonyms in SQL. Remember their distinct characteristics and choose the appropriate object based on your specific needs. Thanks for watching and don't forget to like and subscribe for more SQL tutorials. Welcome to this session. In this session, we will explore the scenarios where a function cannot be called from a select query in SQL. Understanding these limitations can help you write better queries and avoid common pitfalls. Let us get started. First, let us quickly review what functions are in SQL. Functions are reusable code blocks that can perform calculations, transformations, or data retrieval tasks. They can return scalar values or even tables. However, there are specific cases where you can't call them directly from a select query. The first scenario involves functions with side effects. If a function modifies data, like inserting, updating, or deleting records, it cannot be called from a select query. Select queries are meant to retrieve data without altering the database state. Next, functions that return non-scalar values cannot be used in a select statement. A select query expects each column in the result to be a single value. If a function returns a table or cursor, it cannot be directly included in the select. Additionally, functions that include out parameters may not be callable from a select. These parameters are intended for procedural operations rather than data retrieval, which conflicts with the purpose of a select query. User-defined functions that can raise exceptions or errors present another limitation. If a function encounters an error during execution within a select, the entire query can fail, leading to undesirable outcomes. Finally, keep in mind that different database systems have their own specific restrictions regarding function calls in select statements. Always refer to your database documentation for precise guidelines. If you encounter these scenarios, here are some workaround. You can call the function separately, use subqueries to handle non-scalar result, or modify the function to return a scalar value if possible. In conclusion, understanding when a function cannot be called from a select query is essential for writing efficient SQL code. Thank you for watching and don't forget to like and subscribe for more SQL tutorials. Welcome to this session. In this session, we will explore what a trigger is in SQL, how it works, and look at some practical examples to understand its applications. Let us dive in. A trigger is a special type of stored procedure that automatically executes or fires in response to certain events on a specified table or view. These events can include actions like inserting, updating, or deleting records. There are different types of triggers based on when they fire. Before triggers run before an insert, update, or delete operation. After triggers run after an operation is completed. Instead of triggers are used in views and replace the standard action with a custom logic. Here is an example of a before trigger. This trigger prevent negative salary. Check if the new salary being inserted into the employees table is negative. If it is, the trigger raises an error preventing the insert operation. Next, we have an after trigger called log employee updates. This triggers fires after an update on the employees table. It logs the old and new salary into an employee log table, keeping track of changes for auditing purposes. Lastly, here is an example of an instead of trigger. The update employee view trigger fires instead of a standard update on a view called employee view. It updates the underlying employees table directly, allowing for controlled manipulation of data through the view. Like any tool, triggers have their Pros and cons. Advantages include automation of process and enhanced data integrity. However, they can add complexity to your database and may impact performance if not used judiciously. Triggers can be used for various purposes, including data validation to ensure data integrity, auditing changes for tracking, enforcing business rules by automatically applying logic during operations. In summary, triggers are powerful tools in SQL that allow you to automate actions based on specific events. Understanding how to effectively use triggers can enhance your database management. Thank you for watching and don't forget to like and subscribe for more SQL tutorials. Welcome to this session. We will explore the key differences between a standard view and a materialized view in SQL. Understanding these differences is essential for optimizing database performance. Let us get started. A view is a virtual table in SQL that provides a way to present data from one or more tables. It does not store the data itself. Rather, it stores a query that generates the data dynamically whenever the view is accessed. Here are some key characteristics of views. They do not share data physically. They reflect the data in the underlying tables. Views are always up to date, providing real time data whenever queried. They can simplify complex queries by encapsulating them in a single object. A materialist view, on the other hand, is a database object that stores the result of a query physically. Unlike a regular view, it saves the data, allowing for faster access at the cost of real-time accuracy. Key characteristics of materialized views include they store data physically, which can improve query performance. However, since they store a snapshot of the data, they need to be refreshed periodically to reflect changes in the underlying tables. Let us summarize the key differences. A view does not store data and is always up to date, while a materialist view stores data physically and requires refreshing. Materialized views typically offer better performance for read operations, especially for complex queries. Materialized views are ideal for reporting, data warehousing, and scenarios where performance optimization is crucial, especially for large data sets. In summary, both views and materialized views serve important purposes in SQL, but they have distinct characteristics and use cases. Understanding these differences can help you make informed decisions when designing your database. Thank you for watching and don't forget to subscribe and share.